and good day. For the Parit Sulong Water Treatment Plant, we are proposed a raw water intake at the Sungai Simpang Kiri with a 12.7 km square catchment. Our low flow analysis established a critical 7Q 10 safe yield with the 99,360 against our design water demand of 35,631. The system has secured the high availability ratio of 2.79. Therefore, the water quantity is 100 guarantee, allowing our net fast to focus strictly on the treating agriculture runoff. Thank you.
Did you know that a simple mathematical oversight could lift an entire town completely out of water by 2056? This is not a guess. This is actual 13 years engineering infrastructure blueprint for Parit Sulong. So let's break down exactly how we extract raw data project for this feature. Okay, let me start with baseline fact. The data show Parit Sulong had 52,400 residents in 2000, which grew to 71,400 by 2020. To project 13 years from 2026, we use the geometric increase method because compounding rate for 10 years is 16%. So proof that the host exactly will be 124,293 residents. Next, we will look at the consumer habit. By national SPAN guideline, detect that each person will use 215 liters of water a day. We will multiply it with the future population and will add also the world data show that 25% water is lost underground, which is we call as non-revenue water. Finally, we will calculate the extreme stress data for town peak, which is maximum daily demand. The flow rate is 0.495 cubic meter per second, but in the morning we have a morning rush hour, which is it will force us to size everything to 1.031 cubic per second. Okay, so this is how few basic historical numbers are mathematically transformed into a bulletproof water infrastructure blueprint for the years 2056.
For citation, a cascade aerator was selected because it's simple and effective in increasing dissolved oxygen. The required total height of fall is 2.6 meter. A circular collection basin was then designed with an area of 44.6 meter square. A mechanical rapid mixing was selected to ensure uniform dispersion of alum throughout the water. Two parallel flush measures were provided. A tension time of 1 minute was adopted, producing a measure volume of 14.85 meter cube per unit. Will require measure power of 30.2 kilowatt per unit. The daily alum requirement is 1017 kg per day, which corresponding to a monthly storage volume of about 53 meter cube. For flocculation, a mechanical pedal flocculator was selected for control flood formation. Use a volume of 191 meter cube, distribute into 6 tanks. Temperature mixing with G value of 16, 40, and 20 per second was applied to promote flood growth while preventing flood breakage. Clarification, a horizontal flow clarifier was selected for stable particle sealing. 3 clarifiers were designed, each measuring 44.8 length, 9.1 width, and 3.6 deep. Hydraulic check show acceptable flow velocity, Reynolds number, flow number, and wheel loading rate. Therefore, the design provide effective suspended solid removal. For filtration, rapid gravity dual media filtration was selected due to its high efficiency and reliability. 10 filter units were designed with area of 255 meter square and an actual filtration rate of 6.98 meter per hour. Anthracite and silica sand media were used to enhance particle removal. The design meet the recommended filtration criteria.
To conclude the Parit Sulong treatment process, we utilize sodium hypochlorite for self-disinfection and lasting residual protection. The clean water is then gravity feeds into a 16,500 cubic meter reinforced concrete reservoir, acting as a critical hydraulic buffer to balance peak demand and secure emergency supply. And all the detailed calculation is shown in the project. Our system layout directly addresses the site seaward topographical challenge. To overcome the river flat sediment heavy gradient, our intake is positioned on an outer bank to utilize natural scoring and avoid agricultural runoff. For absolute flood resilience, the treatment plant is elevated to 23 meters, while a localized high point reservoir enables efficient gravity feed distribution across Parit Sulong, and the green area is the water supply area, and the yellow point is the location of the WTP and the water intake structure.
Here is the water distribution and storage design for Parit Sulong. To face local low pressure issue, the service reservoir sit at a height point of 25 meter ODL, creating a gravity scheme that cut out pumping electricity cost completely. The system used a 35,631 meter cubic reservoir split into two parallel copper. Each 71 meters wide with a 4.5 meter operating depth. The transmission main feeders and 800 mm mild steel pipe handling a peak flow of 0.495 cubic meter per second. The 24 hours APNet 2.0 model use a right to left closed ring main loop to keep water moving and prevent stagnation. Peak hours pressure stay at 21.4 meters of head, well above the 7.5 meter minimum. At night, static pressure peak safely at 28.6 meters, protecting household plumbing from burn. Finally, velocity stick right in the safe 0.42 to 145 meter per second, safe cleansing sweat, stopping both stagnation and pipe erosion to ensure long-term risk.